Hello, do you hear me?
Yes, we can hear.
Okay. Okay. I think you gave some introduction for me. Thank you for your introduction, and good morning, good afternoon, and good evening, everybody. My name is Akira Tanaka, View5 LLC Japan. Unfortunately, due to their business, two gentlemen from Atlas Corporation are not available today, so I will cover whole presentation. I'll talk about the case study of Eclipse Sirius applied to a RAD tool in Japan. We are very happy to have an opportunity to show our experience with Sirius community, and also will be very happy to receive any feedback you may have. Here's the agenda. After introduction, I'll talk about the RAD tool, Pexa tool first, and then talk about how we approached the result and observation. Okay. This is about the RAD tool. So as you can see from the title, a case study is about applying Eclipse Sirius existing tool, which happened to be a RAD tool. The tool was developed by the company called Atlas. This is in Japan, and the company is actually a spin-out from the former Sun Microsystem Japan, and they are specialized in enterprise application development. The tool is called Pexa, and we have developed Sirius-based Pexa tool, although it's just a part of it. I have been experimenting with Eclipse modeling tools for some time, and especially graphical and textual DSL modeling. I'm also organizing a model-based software development community in Japan. About Pexa tool. Pexa tool is a RAD tool, and which has been successfully applied to various systems in Japan. Those are the numbers of systems that Pexa methodology and tools were actually applied. System size varies from small to large, but I believe that this shows to some extent the maturity of the methodology and tools. Here's a problem to be tackled. In enterprise application development, developers usually face various issues, such as it's hard to get consistent requirement throughout the enterprise organizations. It's hard to get to what extent those requirements need to be implemented, or system boundary, or it's hard to maintain the system once it's deployed and become legacy. The Pexa tool was designed to better handle those issues. For instance, business analysis is done with a very simple line and box type graphical editor. And that was the area we applied Sirius. Here's the feature of Pexa tool. It consists of business analysis tool, business scenario design tool, model transformation tool, runtime interpreter on open source application server, and predefined business domain templates. Since I have played with several RAD tools in the past, and from that experience, I think the distinct feature of Pexa tool is the last item, domain template. There are several aspects of Pexa, which are methodology, tools, and models. There are two types of models. This one, bird eye view model or overview model. This is the target of today's talk. And business scenario model. It's based on business object state transition, but the diagram itself is based on activity diagrams. And those two modeling tools are built on a commercial UML tool and enhanced with a collection of add-ons. So it's like an implementation of UML profile for Pexa modeling. And on the other hand, Pexa runtime engine, it's an interpreter, which runs on top of JBoss that interpret transformed Pexa artifact from business scenario model at runtime. Here's the development approach of Pexa. Essentially, it's easy. Understand the business and refine it and run the model. This is the approach. Today's talk is focused on understand the business part. And the tool for it is called business analysis tool. And in the end of this analysis phase, they will generate several tables. And one of them will become the input to the next phase. This is how Pexa looks at business structure. There's an organization, and there's business operation, this one, between the organization and external entities or business operation within the organization, between departments, for instance. An organization executes business operations, and all of the business operations combined we contribute to the business and business to achieve the business continuity. So business operations change the state of something, which are important element of the business. Main element of business defined by Pexa methodology are something that needs to be managed and has state, and it's called the core. And the other one is actions that need to be done and may affect the change of above states, which is called event. I'll skip the last one. And now it's about business operations and managed cores. Execution of business operations may affect relevant cores state with associated events. Each business operation has associated cores that needs to be identified. So we need to identify which core is referenced or updated or whatever in this business transaction or business operations. Once the core is identified, affecting or affected event by the core will be identified. Now, this shows the diagram element. There are 3 types of nodes, box type 1, and 3 types of relations between nodes. This is the sample overview diagram. Overview means business analysis model. It may look complicated, but the diagram itself is just consists of many simple diagrams. And from that diagram, core event table is generated. This is a list of cores, and for each core, list of events are associated with condition. This table is used when reviewing the requirements with customers. There's another table, event core. It's a reverse relationship. It's generated. And for each action, what other related cores in this event? And this one is the most important outcome of business analysis and will be passed to the next phase. Okay, now, I'm sorry. Now, we can talk about Sirius. The version I used for this project was Obio Designer 10.1, but I also checked it against 11.1, and both worked fine. So here's the requirement for Sirius-based tool for business analysis. The tool should be an Eclipse plugin or a standalone application providing graphical DSL editor for this business analysis diagram without any dependency on external commercial stuff like tools and libraries. And it should implement as much functionality as possible. It should demonstrate what can be achieved without including any Java code. Sorry, I didn't want to write Java code here. And it should allow users to use local characters, Japanese language here. The approach here, it's, I think, quite straightforward. First step is to extract, define an ecore model from Pexa model, then create an odesign to approximately match the original diagramming capability. Then check to see if the editor works properly under Japanese language environment, and then finally modify odesign file to have tables. And the last step is build. So the starting point is this diagram. If you look at this diagram carefully, you will see it's actually very simple. It's a typical node and link diagram. So there are 3 types of nodes and several types of links are used. But the basic meta model is this. I use this for many Sirius projects. So while keeping the basic meta model here, we just added necessary subclasses for node and link, and added one special link here because it connects node and link. Then created an odesign file. It's a very typical odesign file. And the language support. This is the sample diagram I created with the final DSL editor. And thanks to the Eclipse platform and Sirius, I didn't have any issue in using Japanese characters in this. And the builder product, I just used the standard feature-based product build. And the result, the tool I got is like this. I thought I can do some demo here, but I don't know how to switch the screen. So the demo, I'll skip the demo. Anyway, you can see that this is a class diagram kind of box and line. And here's a palette. The interesting part is a table. From that diagram, we can generate a table, but the table is, in my case, a link-based table. So for this, I didn't show the link ID, but it's a list of links which contains source, target, and conditions. And when you click here, you can get the sorted table here. And you can export this as an CSV file. And this is for human consumption. And since we sorted by the source name, and since we added this prefix to see whether this is an event or core, so the table consists of 2 blocks. The upper one is event core, the lower one core event. So I provided this tool to the original developers at least, and found that tool users need to adapt to Eclipse Sirius look and feel. Since I didn't want to write a Java code, I didn't implement the features they request. Those are the ones I didn't do. One thing is about usability. They wanted to create multiple links at once by selecting multiple nodes, boxes, and applying one command from the palette. And the second one is text table formatting. If you compare the table I showed before with the table generated from the Sirius editor, you can see the need for having capability for formatting for lines and fonts. And the last one is about platform integration. There was a request to add context menu to model elements within Project Explorer so that users can navigate to a model element in the dialog. It's like go to the diagram element. By the way, if you know how to do it without using any Java code, please let me know. I would be very appreciated. And there's 3 possible future work, except for refining the tool using Java code. One, the A is to develop business analysis model to business scenario template model transformation. At this moment, this generates table, and there's a person in here who work using this with other additional information and define the input of this. But it may be possible to do something here. And for the second tool, we can apply Sirius and Xtext both to business scenario tool. Currently, it's as I said, it's activity model based, but I think it's possible. And the last one is bring the tool chain to the cloud or on-premise server. And this may take some time, but it's worth trying to do this. So we have applied Sirius to RAD in Japan very successfully, although it's just one, but it's a Sirius-based solution. And I think we have achieved about 80% of existing tools functionality without writing any Java code. And the reasonable language support was there by default by Eclipse and Sirius. So I think we will continue this journey for the time being, and your feedback would be very appreciated. And we'd like to thank Obeo and Sirius community members for making this excellent tool available as an open source. This concludes my presentation. Thank you very much for your attention.
Thank you, Akira.